In previous lessons, we've seen how to solve quadratics with a few different methods. For instance, if I were taking a look at number 1 here, I would notice, well, x squared plus 2x minus 15, that one actually looks like it's nice and factorable. So I'd probably want to start by factoring that. And once it's in factored form, it's fairly easy to solve because it's equal to 0. If I just set x plus 5 equal to 0, then I can figure out then that x would have to equal negative 5. And therefore, if I plugged negative 5 in for x, I would end up with 0 times something. It doesn't even matter what the other one is, because 0 times anything is 0. And by the same reasoning, we would also know that positive 3 would work. And so just by factoring it, we could get the solutions. Number 2 looks a little bit trickier, but actually that one is also factorable. And if we can factor that, we can also still solve it, because in this case, of course, we're just doing 5x plus 1 equals 0 instead. Now, of course, that one isn't quite as simple. We end up getting a fraction or a decimal, depending on how you choose to present it. But we can still get the solution from the factored form. Number 3 is where things start going sideways in that regard, because in number 3, it's not factorable, but it can still be solved. And that's what we're going to be looking at today, is a way that we could solve any quadratic. Now, as I jump into this though, a lot of people will say, oh, well, if it could be used for anything, then I should always use it. I wouldn't necessarily say so, because something like factoring tends to be much faster and it's more reliable. If something is factorable, it is better to factor it in order to solve it. We really are just going to resort to other methods as they get tougher, particularly because this method is a little bit more prone to error if we aren't super careful. Today we're adding the quadratic formula into our quadratic toolbox here. So add this into your notes. Go ahead and pause the video while you write it down, and then resume it once you have it written down, please. All right, so hopefully you have this written down in your notes. So a couple little details. First of all, notice that our quadratic has to be set equal to 0. If it's not set equal to 0 at the start, you would have to set it equal to 0. You'd have to do a little bit of algebraic manipulation before you could use this, because this only works when it's set equal to 0, just like the factoring method. Now, because of that, any solutions that we get out of this are also known as just zeros. But just so you know some vocabulary that you'll see pop up here and there, they also go by the name of roots, and they're also the x-intercepts on the graph. So that's all talking about the same stuff as we go. So we're going to go and actually solve that problem that we saw in the first slide using the quadratic formula now. Now notice it says round to the nearest hundredth. Please realize that is only something we have to remember for the very end. You do not want to do any rounding in the middle. Otherwise, it's almost guaranteed that your answer will be off by just a little bit. And that little bit often is all it takes for it to be marked wrong. All right, so let's go ahead and start plugging in here. The first thing I need to know is what those a, b, and c values are. All that goes back to that general equation of a quadratic of ax squared plus bx plus c. That's where we're getting the a, b, and c as we talk about this. Notice the a, b, and c are always just numbers. The x is not part of the a, b, or c. All right, so now that I know what a, b, and c are, I can now go ahead and plug each of those values into our quadratic formula here. So all I did was just take them and plug them in. Now notice that when I plug them in, I do want to put parentheses around the numbers. It just makes it a little bit cleaner to look at, and it does help avoid some errors that can crop up, especially involving negatives. All right, so from here, now it's basically a problem of just making sure we use the proper order of operations. So in order of operations, the first thing we do is we do anything inside of the parentheses. Technically on this one, all of this stuff that's inside the square root would be acting as if it's inside of parentheses, because all of that is in the same function. So we really have to do all of that stuff before we can do anything else. Now, you'll notice we play a little bit loose with a couple of those things, but that's really technically what we have to be doing first. Now, within that square root, you notice the very first thing is the exponent, because there's exponents, subtraction, and multiplication, and we're going to have to do the exponent first, then the multiplication, then the subtraction. So, notice what I did here. I first just went ahead and said, well, if this is -7, then I'm just going to write as -7. Technically, maybe I should have waited on that, but I know that we can do that we know that that's the same, so yeah, I just went ahead and jumped into it. The 7 squared became a 49. That's really technically what we had to do at that point. But because the next thing that I would need to do is then do the multiplication inside here, and that didn't have any impact or connection to any other steps, I went ahead and did that multiplication. Now, one thing I want you to note, though, is that the negative that was sitting out front here is still sitting there. The most common error that I see when people do the quadratic formula is that they look at that original setup up here and they think to themselves, -4 times -2 times 5, and they do all that math and they get a positive 40, but then they leave that minus sitting there. But it was already used. And so in order to avoid that, you'll notice what I recommend instead. You'll notice that I just ignore that subtraction symbol in there, and I just say it's going to be subtracting whatever I get from doing that. Now, that being said, there's a lot of people who are very reliable by treating it as -4, but the key there is reliable. You have to be able to do it right without making that error every single time. All right, now that I'm at this point, I need to do that subtraction that's on the inside of that square root. So 49 minus a -40, that's the same as 49 plus 40, so that becomes the 89. Now at this point, now we got to break out our calculator, because it does say to round our answer to the nearest hundredth. If we were supposed to just leave our answer in exact form, that would actually be what we have here already. Because exact form says break it down as much as you can without actually having to turn something into a decimal that gets rounded. So we could stop there in some problems if it says to leave your answer in exact form, but it didn't, of course. It said round to the nearest hundredth, so we got to break out the calculator. Now, for doing this calculation, it depends on the type of calculator you have, and this is going to be one of the things you got to do is get to know how does your calculator actually handle this. If you're on more of a graphing calculator, tends to be the graphing calculators at least, where if you type in -7 plus the square root of 89, then it actually starts displaying that just like that on your calculator screen. If you are seeing that, you can type it in just like that and you're going to be fine. Notice I just did plus there. We got to do it once where we calculate it with the plus, and then we got to do it a second time where we plug in the negative and do it that way. However, if your calculator isn't that sort, and it's not displaying the stuff on your screen as you type it, but it just pops out the numbers, you'd actually end up having to do the square root of 89 first, and then you would have to say plus -7 and get that answer. Remember to press equals at that point, by the way, because the next thing you do is you then divide by the -4. And if you don't press that equals button, it's only going to divide the -7. So you need to say equals so that it gives you the answer from the whole top. Now I want you to have a chance to try this on your calculator. These are the two answers we should get out of this. So go do those calculations on your calculator and make sure you can get those numbers out of it. If you are having a lot of trouble with that, this would be a good time to be checking in with me maybe and asking a question so we can actually look at that together and I can make sure that you know how to use that calculator, because without being able to use it for this, these aren't really going to be very doable. All right, now as we proceed, I was talking about rounding your answer versus having it in an exact form. You might want to actually write that down as a reminder to yourself just because every now and then sometimes people end up struggling with questions, especially like on WAMAP, because they're doing it right, but they don't realize they're putting it in the wrong form. And I want you to always make sure that you're at least remembering to check that form as you go. All right, here is our next question. Actually, our last question that we're going to be taking a look at here together. I'd like to see if you can solve this one yourself. And so I'm going to be walking through it, but what I'd like you to do is write it down and try actually solving this yourself before you see me go through it. And then as the video is playing, I'll be talking about how I'm doing it and what all we're doing along the way. And when I get to that point where either you made an error or you're feeling stuck and couldn't go past it, you'll get that piece, then pause the video again and continue from that point. And continue working as far as you can. See if you can get to the very end from there. And keep always trying to be working ahead as far as you can, because that is a huge help when learning this sort of problem. All right, so let's go ahead and start solving it. The very first thing we need to do in order to solve a quadratic is we actually need the whole equation set equal to 0. Right now, this thing is set equal to 9x. We don't want it to be staying that way. So in order to make it equal 0, what I'm going to do is I'm going to subtract 9x from both sides. Now, when I subtract the 9x from the right side, there's no x's already over there because this is an x squared, not an x. Therefore, it's just going to be a 9x stuck right there in the middle. Now, I do want to put it in the middle because I always like to keep that same order where we go x squared, then x, and then just the number, the constant term. All right, so now from here, now that I have it set all equal to 0, now I can go ahead and start solving it. Now, I would recommend that you start by trying to see, can you solve it by factoring? Unfortunately, though, no, this one does not factor nicely. So that points us to, yeah, as you might expect, given the lesson topic, I'm going to be using the quadratic formula here. Now, in the quadratic formula, then, my a value is 8, b is -9, and c is -12. Remember, ax squared plus bx plus c. All right, plug into the quadratic formula, which, yes, you should have in your notes, and even should be working on memorizing, by the way, as well. And then I just plug the numbers in. Notice I'm not changing signs as I plug them in. And yes, I am putting parentheses around everything as well. And those parentheses are going to end up being particularly useful. For instance, here at the start, I see I wrote -9. Now, I know a lot of you will want to just write that as, oh, well, I'm just going to write that as 9. Be aware, though, that sometimes what happens is we say, okay, so I know that b is -9, and so I'm going to plug that in for -b. Okay, so -9. We have the negative in mind, but we forget to use it both times. And so it's a common error that can crop up. So that's why you'll actually see me write it out as -9 before we do anything else. Another spot where you'll notice the advantage of putting in the parentheses is right here. And this is something where you're going to have to be careful when you do this on your calculator. Because I see a lot of students where they will type into their calculator -9 squared. And the calculator tells them it's -81, and they believe it. But it's not, right? If you square a negative, you're doing a negative times a negative, which is always a positive. By putting those parentheses around the -9, you remind yourself that you're squaring the negative as well, and not just the 9. If you were going to type this in your calculator with the negative in there, you'd actually have to do it the same way in order for it to give you the right answer. You'd have to tell it parentheses around the -9 and then square it. So if you are doing this problem and you're getting an error, like you're not getting the right answer, or your calculator says, I can't take the square root of the number you just gave me, that may well be the cause of it. So as we proceed, notice I have a positive 81 there. And then it's going to be minus a -384. Do again note the minus the negative. Otherwise, you might have a tendency to only use one of those negatives and it would throw off your answer and your calculator would throw a little fit on you because it won't be able to do it if you just do -384. And so I'm going to end up having to do the square root of 465. This is now the point where I plug it in the calculator, and I am supposed to round to the nearest hundredth, so 2 decimal places. Therefore, those would be my final solutions. This problem now is done.